Hello, welcome back! Now, in the previous video, I introduced you to the concept of the greedy method. But why should I care about this method? Why can't I just use, try and error or some other way, or try a few different combinations to see what works? Good question. So let me demonstrate the powers of the greedy method with this example. Let's say that you're planning a weekend getaway to Johor Bahru in Malaysia, right? You want to shop till you drop and eat until you explode. You have a couple of destinations that you want to visit, and to maximize your time in Johor, you want to minimize the amount of time traveling. Now, it's very easy to plan a trip if you have like maybe 2, 3, 4 or 5 locations to visit. It's very easy to work out by try and error what is the shortest route. But what happens if you increase the number of locations? What if you have 6, 7, 8, 9 or even 10 places to visit? How do you find the shortest route? Many real-life problems are like this. When you increase the scale or the size of the problem, the complexity of the problem increases. So let's say you have 10 places that you want to visit for shopping and for food. Some of these places are places I regularly visit when I go across the causeway. We have the Puteri Harbour to see the nice view of the sea. You have IKEA Tebrau, the biggest in Southeast Asia. Paradigm Mall, wow, a really huge mall. Or KSL City Mall, really big. People like go there for massage or manicure, pedicure, right? There's the brand new R&F Mall. If you haven't been there, it might be worthwhile checking it out. There's this place called Eco Shop at Campus. It's cheaper than Daiso. There's also this Hyap Ju Bakery and Biscuit Factory. Wow, a lot of delicious confectionery and pastries that you can buy and bring home. Now, we also have places that we want to eat. There is Faculty of Caffeine. Haha! And then there's my favorite roti prata place, or as the Malaysians call it, roti canai, restaurant Syed SJ. And then there's a really good dim sum place, restaurant Kim Cheng Dim Sum. You have to start your trip from the customs and immigration checkpoint. And for this discussion, okay, you don't have to worry about coming back to Singapore. At the end of the trip, after you visited all 10 places, you just retire to a lovely country resort in Johor. Spend a lovely night there, and then in the morning you can slowly make your way back to Singapore, right? There are 3 ways to find a solution. One way would be to exhaust every possibility until you found the route with the shortest distance. This is known as the exhaustive search method. You could do this if the scale was much smaller, but for this problem you have 10 locations. That's 10 factorial, which is 3,628,800 possibilities. Ain't nobody got time for that. By the time you're done planning, win already, you don't need to cross the causeway for a holiday. The weekend is over and you need to go back to school. Another way you could try is to attempt this by trial and error. But don't forget, we've got 3.6 million possibilities, right? So how do you find the shortest path? Finding the shortest route is like finding a needle in the haystack. You might be able to come up with a route, but with 3.6 million possibilities, odds are that the one that you found is still very long. Only if you're lucky will you be able to find a decently short route. So good luck if you're going to use try and error. Now, it's for reasons like this that we need to resort to the greedy method. So, just to recap, the greedy method is all about following a simple and systematic rule. So, what can we do to ensure that we get a short route? What rule can you come up with? So, let's open up our lecture activity spreadsheet. Here, we have a table of all the distances that you can travel from one location to another by car. Yes! Wow, we're going to drive from one place to another, so you don't have to walk until our feet hurt so bad. This table on the spreadsheet is also known as an abstract map. Now, since we want to minimize the amount of traveling required, a simple greedy rule would be to choose the nearest location. Choose the next location that is nearest to you. Alright, so let's run through the process, shall we? Starting from the customs and immigration checkpoint, where do we go next? So let's look at the table. The nearest location here will be KSL Mall. It's just 2.9 km away. Okay, so let's go there. Okay, now that we're at KSL Mall, where do we go next? Now, important, we need to cross out the customs and immigration checkpoint. Since we came from there, right? We don't want to consider that again. So, what's the next nearest place? The next nearest place is R&F Mall, which is 4.3 km away. Okay, so let's go there. Okay, so now we're at the R&F Mall. Where do we go next? Where's the next nearest location? Again, don't forget to cross out KSL Mall since we've already visited the place. Let's take a look. It is the Hyap Ju Bakery and Biscuit Factory. Okay, that is 1.5 km away. Okay, come, let's go there. Drive. Do you understand how it plays out? How we can find our shortest route using the greedy method? If you do, feel free to pause the video and try to complete the route on your own. If not, you can continue playing the video and I'll run through the sequence on the screen for you.
I wanna go to shop and eat in JB. Buy toilet paper in bulk across the causeway. I am just a cheapo who wants a good deal. Eat and shop until my heart's content. Yeah. Whoa, 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 whoa. Drop my passport and cross the causeway. Whoa, 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 whoa. Can't wait to buy discount toilet paper. Need to go to JB. I need to fill my belly. Need to go to JB. Make my wallet empty. Go.
And just like that, we now have our route. Here's our total distance traveled. Now, if you stare long and hard at this table, you may find a route that's actually shorter than the one that we found using our greedy method. That's okay, alright? The greedy method is great at helping us find a solution that works. Sometimes it's the best solution, the most efficient solution, but many times it's not. What's important that it's a quick and easy method for finding a decent solution, especially in situations where it's impossible to find a solution by try and error due to the size and complexity of the problem. Now, let's return to the greedy rule that we were using. The rule was to go to the next location that's nearest to you. Here's the big question. How then do we convert this into an algorithm? Let's begin this conversion process by reviewing what we did so that we can come up with our algorithm. Again, we need to apply decomposition to outline the different parts of the process. 1, there's definitely a loop. 2, during each run of the loop, we need to find the next nearest location on the list of remaining locations. 3, well, we definitely need to go to the next location. 4, we'll need to write down the location into our route. We need to record that, right? 5, we need to mark that location as considered so that we won't look at it again. Now, I'm going to verbalize the entire thought process on how we go about converting something from an outline to pseudocode. This may seem a little bit boring or mundane, but I hope that it will demonstrate to you how we do that conversion process, how we go about developing a clear algorithm from this outline, alright? Okay, now let's settle the loop first. We know there's a loop where we keep repeating the act of finding the next nearest location. When do we end the loop? When we have considered every location on our list. Now, in lecture 4, I introduced you to the concept of loops, and I introduced you to the for loop, the do while loop, and the do until loop. In this case, since it's clear to us when we should terminate the loop, we can use the do until loop. So let's start first with our outer layer of pseudocode. Do until all locations are considered. And then later on we'll fill in the blanks, end loop. Okay, now that we have this, how do we find the next nearest location on the list? Well, we need to look at our list of locations and refer to the distances of those locations from our current location. And here's the key, right? What makes our method greedy is to always pick the location nearest to us. Or in other words, to pick the location that has the smallest distance value. That's a mouthful, right? How do we put that in pseudocode? Well, it is pseudocode, so you're not expected to write in any proper coding or programming syntax, right? Just enough human language to get the point across, right? So, we can express it in simple English like this. 1, refer to the table of locations. Next, find the row in the table that corresponds with the current location. Next, find the column in that row that has the lowest number. Next, set the next location equals to the location that corresponds with that column. Okay, so let's put that chunk of code into our loop. Here's how it looks like. Do until all locations are considered and blah blah blah, the rest of the code, end loop. Alright, now we actually have to go to the next location, or at least pretend that we're going there, right? So this step is a little bit complicated. Why? Because in our first run, we must start from the customs and immigration checkpoint. And it's only in the subsequent runs that we begin from wherever our algorithm decides. So we can use a set of conditionals to decide what to do. So we can write it like this. If this is the first run, then set current location equals to customs and immigration checkpoint. Else, that means if it's not the first run, set the current location equals to the next location. Alright, so let's add that into our pseudocode. And now our code will look like this. Alright, Let's add the instruction to record the next location on our route. We can express that as add next location at the end of the list of routes. Now we must not forget to mark the visited location as considered. This will help us to distinguish which locations to consider and which to ignore because we have visited them. So to mark it as considered, we can say something like this. Mark next location as considered on the list. Well, it looks like we're done. Are we? Well, we have a bit of a problem. Let's look at what we have now. Okay, this is our code on the screen. Can you see what's missing? We are marking locations as considered, but when we identify locations that are near to us, we are not considering whether those locations have been considered or not. In fact, we may end up revisiting the same location again and again and again and again. That's not good. So what can we do? Well, we can fix this by modifying this particular line of code from find the column in the row that has the lowest number to this. Find the column in that row that has the lowest number that is not marked as considered. Now, here's our code in its entirety. Wow, look at that. As you can see, a slight modification in our pseudocode will now instruct us to ignore the ones marked considered, the ones that we have already visited. Yeah, and our algorithm for planning our holiday is done. We've got a short route. Ta-da! Now, before we cross our causeway and start our holiday, we need to pause and ask ourselves this question. Is this really the best solution? The best answer? One thing we need to be clear about with the greedy method is that it is a quick and simple way to find a solution to a complex problem, but it may not always present us with the best answer. In our case, the greedy method found us a route that's possibly far shorter than any other route you could find using trial and error. But if you keep staring at this route, if you keep staring at the table of distances, the abstract map, you might find that tweaking some of these locations around could give you a much better route. Greedy methods are only a starting point to help us find simple solutions. Sometimes they give us the best answer, sometimes they don't. In the weeks to come, I'll teach you some techniques to help find ways to optimize your greedy solutions to make them better.